related rates problem. A 13-foot ladder is leaning vertically against a wall. If the bottom of the ladder slides away from the wall at a rate of 2 feet per second, how fast is the top of the ladder sliding down the wall when the base of the ladder is 5 feet away from the wall? So let's look at what's happening here. Here's our ladder sliding down the wall. And we're going to say when it gets to be about 5 feet right here, how fast is this falling? How fast is this h changing? And notice that as we get down here, the ladder starts falling a lot faster. Okay, it starts out pretty slow, but as we get over here, it goes pretty fast coming down until it just goes boom down at the bottom. So that's our situation. So let's draw a picture. Here's our wall. Here's our ladder. All right? We have y. We're trying to find y prime. We have a 13-foot ladder. We've got x. We know x prime is 2 feet per second. So we need an equation that relates all of those things. So we'll use the Pythagorean theorem. X squared plus y squared is L squared. Differentiating that, everything's changing with time, we're thinking. So differentiating gives us 2x x prime plus 2y y prime equals 2l l prime. Now when we fill in what we know, notice the length of the ladder here isn't changing, so L prime is 0. So on the right-hand side of this equation, we're going to end up with 0. On the left-hand side, we have 2. At the point we're interested in, x is 5. And they told us that x prime is 2 because the ladder's sliding away at 2 feet per second. And we have 2. We don't know either y or y prime. So that's a problem. We have 2 unknowns. So we're going to use the Pythagorean theorem to find y at the time we're interested in. So the point we're interested in, x is 5, the ladder's 13. So 5 squared plus y squared is 13 squared. So that gives us y equals 12. So filling in above, 10 times 2 is 20. 2 times 12 is 24y prime equals 0 on the right here. Solving for y prime gives us negative 5/6. So the top of the ladder is moving down the wall at a rate of negative 5/6 feet per second at the exact moment when the ladder is 5 feet away from the wall. Let's just come over here for a second. If we look in this little box at the right, show the function and the tangent, you can see as the ladder slides, the tangent line gets steeper. Okay, so it's getting steeper and steeper. If we look in particular at the moment when the ladder is 5 feet away, we see that we get negative 0.814, which is negative 5/6, assuming I stopped it in exactly the right point, feet per second. That's how fast the ladder is sliding just at that moment. And again, as we saw before, and you can see on this picture, that as the ladder gets closer to the ground, it starts getting faster and the slope of the tangent line is higher.